Good morning, class 8 students. Today in chemistry we will continue with the last video of the 6th chapter of chemical reactions. We see that in the last video 4 we studied about the examples of displacement reactions where more active element or metal atom displaced a less active or an atom placed lower in activity series. We studied about double decomposition reactions, which also included precipitation reactions and neutralization reactions. Today, children, let us see yet another precipitation reaction, which is given here, where AgNO3 or silver nitrate solution was added to a test tube containing NaCl solution. We see here, children, that this is a test tube where NaCl solution is filled, and here we are pouring AgNO3 solution into this test tube. Now when we pour this, we see that a white precipitate of silver chloride is formed. A white precipitate of silver chloride is formed, and another compound, sodium nitrate, is formed. So silver chloride we see here is precipitated here. It can be seen precipitated at the bottom of the test tube. So we see here that this is a precipitation reaction. Also in this chapter we see there are exothermic and endothermic reactions. We know that exothermic reactions are reactions which give off energy, which is also produced in the form of heat and light. Thus the reactions which give off energy are called exothermic reactions. An example of exothermic reaction is given below. Here you see in this particular picture that we are using nitroglycerin, and nitroglycerin is an explosive which is used to break and move the rocks when we have to make railway paths or we have to make roads in the hilly terrain. Then we use nitroglycerin. The complex molecule of nitroglycerin converts into four gaseous products, which are carbon dioxide, nitrogen, oxygen, and water vapor. And another example of exothermic reaction is when quicklime or calcium oxide is placed in a beaker containing water. Then water becomes very hot and starts boiling. So when it becomes very hot and starts boiling, it gives out heat energy. This is also an exothermic reaction. Also a reaction of magnesium ribbon burning in the presence of air with oxygen gives magnesium oxide, and heat energy and light energy is released. So we can see when magnesium ribbon is heated from its tip in flame of Bunsen burner, it catches fire and burns with a dazzling white flame. So these are some of the examples we see. Likewise, we come across endothermic reactions. The endothermic reactions are reactions in which energy is absorbed, and these endothermic reactions involve reactions like sodium bicarbonate. So sodium bicarbonate here absorbs heat energy to break into three components: sodium carbonate, water, and carbon dioxide. Then we see that the dissolution or the breaking down of ammonium chloride in water is also an endothermic process, because this also absorbs energy. Then we see that there are various kind of oxides that are important, and we see that these oxides are of four types. When the elements they combine with oxygen, they form oxides. Oxides are classified as follows. We have acidic oxides and we have basic oxides, we have neutral oxides, and we have amphoteric oxides. 4 kinds of oxides are there. But in acidic oxides, we see that here nitrogen oxide combines with oxygen of the air to give nitrogen dioxide, and likewise nitrogen dioxide in the air, it combines with water that is present in the air and oxygen to give nitric acid in the atmosphere. Likewise, we see sulfur that is released by automobiles, etc. It rises up in the atmosphere in the presence of oxygen, forms sulfur dioxide layer. The sulfur dioxide layer, it again combines with water to form sulfurous acid in the atmosphere. Likewise, we see carbon is also there, which is emanated by factories, etc. It also goes into the atmosphere, combines with oxygen to form carbon dioxide. Carbon dioxide further, in the presence of water vapor or water present in the air, makes carbonic acid. I want to discuss one reaction here to show that sulfur dioxide is an acidic gas. How we can show this? When sulfur dioxide is coming out of a test tube, we see that a blue litmus paper is kept on top of the test tube, and this blue litmus paper, it turns acidic red. This shows that sulfur dioxide is an acidic gas. So we see these are all acidic oxides that we were talking about here. Then we come to the basic oxides. The basic oxides are oxides that are formed by the reaction of metals with oxygen. Like potassium reacts with oxygen to give potassium oxide. Further, potassium oxide in the presence of water vapor or water, it gives potassium hydroxide, which is a basic oxide. Again, we see calcium is a metal which combines with oxygen to give calcium oxide, and calcium oxide further reacts with water to give calcium hydroxide, which is another basic oxide. Then we come to magnesium, which combines with oxygen to give magnesium oxide, and magnesium oxide further reacts with water to give magnesium hydroxide. Likewise, we see that sodium is a metal which combines with oxygen to give sodium oxide, and further sodium oxide reacts with water to give sodium hydroxide. So we see the basic oxides are also formed. Now here we see that the red litmus paper is given. Here is an NaOH solution, or it is a basic solution, basic hydroxide. Now in this, when red litmus paper is dipped into the NaOH solution, the red litmus paper turns blue, showing that sodium hydroxide is basic in nature. Then we come to the neutral oxides. In the neutral oxides, we see that these oxides are neither acidic nor they are basic. They are neutral to the litmus paper. They do not show any change in the litmus paper. For example, we see carbon combining with oxygen to give burning carbon monoxide. Likewise, we see carbon monoxide is formed when carbon burns in insufficient supply of air. Then we also see here nitrogen, it combines with oxygen to give nitrogen oxide, and so this nitrogen oxide is formed when lightning takes place at 3000 degrees Celsius, and so nitric oxide is produced. Likewise, we see hydrogen and oxygen on electric current, passing of electric current gives water vapor, So we see that all these carbon monoxide, nitrogen monoxide, and water vapor, these are all neutral oxides. Now let us talk about amphoteric oxides. What are amphoteric oxides? We see that the oxides which react with acids and bases to form salt and water are known as amphoteric oxides. Like we have the reaction with zinc oxide. Zinc oxide here reacts with hydrochloric acid. This is a base, this is an acid. They combine to give a salt, zinc chloride, and water is released. So this is an amphoteric oxide. Likewise, we see zinc oxide combines with NaOH, which is an alkali, to give sodium zincate, a compound called sodium zincate, and water is given. Likewise, we see reactions of lead oxide with hydrochloric acid giving lead chloride, precipitate, and water, and also lead oxide with sodium hydroxide base to give sodium plumbite, Na2PbO2, and water is given out. Then we see reactions of aluminium oxide with HCl first to give aluminium trichloride and water. Also we see aluminium oxide combining with alkali or with base sodium hydroxide to give sodium metaaluminate and water. So these are amphoteric oxides, and amphoteric oxides are those which react both with acids and with bases to give what, children? To form salts and water. So all these ZNO, PbO, and aluminium oxide, these are examples of amphoteric oxide. So with this, the explanation of this chapter is over. Wish you all the best for the study of this video. I will send the assignment soon. Thank you.